Hello YouTube friends, in this video I'm going to be showing you how to create an inward rotating torus using Runiter's 3D graphing calculator. So what I'm going to do is create a new file and I'm going to put parametric equations related to a torus into that file. Before I plug these parametric equations in, I will need to add a few variables to this file. So I'm going to put A is equal to 1 here. I'm going to put B is equal to 1 here. I'm going to put D is equal to 1 here. And I'm going to put T is equal to 1 over here as well. Next, I'm going to plug in the parametric equations for a torus. So I've selected this box over here and I'm going to go down here and I'm going to select parametric. Okay, and for X I'm going to put in A plus D times cos V multiplied by cos U. For Y, there is going to be something similar. Instead of cos U though, you put sin U. And for Z, you have B plus D times sin V. Okay? And these are the equations for a torus. Now the reason why this torus looks a bit like an apple is because A is equal to D. They are both equal to 1 at the moment. And for the inward spinning torus that we are going to create, A has to be equal to D. So this is perfectly fine. Just before I carry on, let me tell you, if you want to know how these parametric equations were derived, visit mathematics.proofs on Instagram. Just below this YouTube video, you will find a link to that page, and there you'll see how these equations were derived using trigonometry and Pythagoras' theorem, etc., etc. So the next step here will be to wireframe this graph over here, okay? And we do that by going down here and changing surface into wireframe, okay? And what I've found is that the perfect resolution for this animation is going to be 7, okay? 7 is a very good resolution. So let's set that. As you can see, 7 wireframes very neatly, just like this. Now going off on a bit of a tangent, if I change this A over here into, let's say, 3, you can see that we get a donut. So this is definitely a torus. But for the purpose of the animation, we are going to make A is equal to D. Okay, so we will make it 1 again, like this. Now let's get some inward rotation happening. To do this, I'm going to change the angle V into V plus T. Okay, and on all the equations. So V plus T over here, and V plus T over here as well. Okay, now what you'll see is that if I press play for T over here, which lies between -10 and 10, we will get an inward rotating torus, like this. Okay? Now I can adjust the speed at which things are rotating, and I'm going to show you how to adjust it accordingly to get a nice animation. Okay, I've stopped T for the time being, and what I'm going to do is make this animation transparent. So I'm going to go down here and click on transparency. Okay, and what I'm also going to do is select single here for wireframe. Now let me reduce the transparency even further. As you can see, we get this nice see-through torus if we reduce the transparency right down to the bottom. Okay? We get something looking like this. And if we press play for T over here, we get an animation. But this animation needs to be adjusted because it doesn't look very smooth at the moment. To make this animation more smooth, let's change the range of this graph. We are going to ensure that the angle U sits between 0 and 2 times pi. The angle V is going to sit between minus pi over 2 and pi over 2, like this. With these settings, the animation is going to run far more smoothly. Check this out. So I'm going to press play for T over here just to demonstrate that. Okay, the animation is much smoother. It's not perfect though. There are still things that need to be done. The next step now will be to make T lie between 0 and 10. Okay, let's see what the effect is. Now, since this box is selected, we are going to go down to graph type and select 50 for steps to slow down the pace of T. Okay? And as you can see, things are much more smooth. Let's see what happens if T sits between 0 and 50. What we get is T moving a bit too quickly. So let's slow it down. For steps down here, I'm going to select 200. Let's see what that does. Yes, we get something that is far more smooth. Can we make it smoother though? Let's make steps 500. Okay, that looks pretty smooth to me. Okay, I like the way that I can see everything happening very slowly. Let me just try to make the animation perfect. I'm going to set T between 0 and 75, and I will also make steps 1000. Let's see what that does. What we get is this animation over here, and it's very smooth. Plus, we can zoom into it, just like this. We get a very nice animation. Now let's see if we can get rid of this grid in the background. I'm going to select the graph, okay, and I'm going to go to axis over here. Next, I'm going to go to appearance, and I am going to remove the ticks on axis and also grids, okay? And that leaves the torus on its own. Now let me click play over here. We've now got this incredible torus animation where it rotates inwards. It looks like a universe expanding and then contracting. That's what makes it very interesting and nice to look at. So this is your torus animation made with Runiter's graphing calculator. If you like this video, do not forget to subscribe to my YouTube channel if you haven't already done so, as there's more work coming up. If you've got any questions, leave them in the comment section. Now, if you require mathematics proofs, visit mathematics.proofs on Instagram. Here I post mathematics proofs nearly every day related to trigonometry, algebra, calculus, differentiation, etc., etc. There are also posts related to creating 3D animations, just like the one you see on this video. Thank you very much for watching this video, and I'll talk to you again soon.